we place on the earphones that I have right now in my ears small sensors. And these sensors, they can capture any electrical activity. So it can be the one that's coming from your brain, your eyes, your facial muscle. And then we have embedded AI algorithms and transforming it into any kind of actions for you to control your smartphone, to control your laptop, to control tomorrow your AR or XR device, hands-free, voice-free.
Welcome to a new episode of XR AI Spotlight, the show that gives the stage to the founders and makers pushing the boundaries of XR and AI. My name is Gabriele Romagnoli, I'm your host, and I'm here today with Yacine Aciakh. Yacine spent over 6 years as a senior AI product manager at Criteo, one of France's first unicorns when he grew multiple products to 100 million in annual revenue. In 2019, he co-founded Wisear with one clear goal: connecting humans and computer like never before. In this conversation, we start by looking into the foundation of neural interfaces.
So I would say that the quest for measuring the human electrical activity starting with the brain or any other is like a long, a lasting quest, right? It's been on since for more than 2 centuries now. Today, I would say there are 2 different main approaches.
What were some of the challenges when building neural interfaces that fit in your earbuds?
I think originally we thought it was mostly a software problem, but then we realized very quickly that we could not have any good AI without a very good underlying data collection and therefore hardware. And then we opened a whole new Pandora box.
He even showed me how he could select, swipe, and even play games completely hands-free.
The way we've been thinking about this is trying to decompose that in 3 steps. Step number 1 is what I would call selection. How do I replace a click or a press of a button? So that can be, for instance, clenching your jaw. The second part is what we call the navigation. What we're doing is we're able to detect simple eye gestures like this, right and left for now. We're going to work on the verticality soon, and being able to use that to swipe through apps, for instance, or navigate, through a very simple interface. Once you have the pointer, once you have the selection, once you have the navigation, how do you actually have complex commands or complex inputs, like text inputs? And for that, we're trying to work on something called silent speech.
We, of course, also talk about accuracy and actually how hard it is to learn for users.
We need to make sure that the onboarding would be super short for you to learn the gesture. And today we are below 2 minutes in terms of the total onboarding. In terms of the missed attempt, so the false negative in this case, we are at 98%.
And lastly, Yacine shared the launch date and price that I felt was shockingly closer and cheaper than what I expected.
We intend on releasing our first product at the end of 2025. So today, the price point that we're aiming is going to be $250, which is going to be kind of aligned with premium headphones.
But before we get into it, I wanted to thank our sponsor Meshy, who made this episode possible. Meshy is a real powerhouse for generating 3D assets with AI. You can start with a simple text or image prompt and get high-quality, stylized 3D models in just a minute. There are 2 features that completely blew my mind. One is the ability to create stylized texture for any mesh, with or without UV. And the other is the ability to edit portions of AI-generated textures like in Midjourney in Painting. The team has been pushing continuous updates, improving significantly the geometry and texture quality, and I strongly encourage you to visit meshy.ai and check out the generous free plan. After that, make sure to use the code XRAI20 to get a 20% discount on your subscription. And now it's time to roll the title and welcome Yacine under the spotlight. Yacine, it is a real pleasure to have you here.
Hi, thank you very much for having me.
So, Yacine, please tell us, Wisear's earphones decode neural signal from facial muscle, eye activity, and let's say the brain. How does that work?
Yeah. All right. So more generally, I think we're using the neural interface term the same way the market is using it. But what we do is that we place on the earphones that I have right now in my ears small sensors. And these sensors, they can capture any electrical activity. So it can be the one that's coming from your brain, your eyes, your facial muscle. Your body is really a big battery. And so everything that you do, every thought that you have creates a specific current. And so our sensors are capturing that signal. And then we have embedded AI algorithms and signal processing algorithms that are using that signal and transforming it into any kind of actions for you to control your smartphone, to control your laptop, to control tomorrow your AR or XR device, hands-free, voice-free.
So can you tell us about these sensors? Like, is that something that you could put then anywhere? Is that something that is independent on the person? What about it?
Yeah, so the sensors that we're using, I'm going to show you one of our oldest other prototype because like that's the one I have next to me. The sensors that we are using are just like they're the same shape and material, so like conductive polymer, so the same shape and material as the one you would have on your regular AirPods. They are made of a specific material though, which is conducting electricity. So your regular AirPod would just be like polymers. These ones are conductive polymer, so they can carry electricity. And the way that's going to work is that you could put these sensors anywhere you want on your body, and you would capture some electricity. If you like, there's a company called Control Labs that got acquired by Meta, and is now the technology behind the neural interface wristband. And so they are capturing the information right here around your wrist. Well, depending on where you put the sensor, it's like a microphone. So if you put it on the wrist, you get the hand. If you put it closer to the head, you get the head, the brain, anything that's near it, right? So that's for the sensor itself. And then it works on everybody because like as weird as it seems, we all have like brain and we all have like a facial muscles and like eyes. So we are able to capture signal on everyone as we are placing the sensors near to the same region. And so the signal is pretty similar from one person to another.
So, I mean, I want to go into a bit later what you can exactly do, right? How do they work? Let's say, what's the output of that neural signal? But before that, maybe how is this different from other neurotech approaches? I mean, for example, Neuralink does something, you guys are doing something very different. Maybe before we get into that, can you maybe set the ground for that?
Yeah. So I would say that the quest for measuring the human electrical activity starting with the brain or any other is like a long, like a lasting quest, right? It's been like on since like for more than 2 centuries now. Today, I would say there are two different main approach. The number one is, the two are like invasive and non-invasive. So invasive is the Neuralink approach. The rationale here is to say, if I want to really understand the brain or any part of the body, I need to put the sensor deep down into the brain. And that's very good because it allows you to get very localized, very precise signal of what's happening at the neuron level. The second approach is the non-invasive approach, where basically you are placing sensors on the outside part of your body, or the skull, so on your skin or anywhere. And with that, you actually get like more of a broader understanding of what's happening. You cannot get neuron by neuron, but you can get a sense of like, okay, what this region of the brain is doing, or what is the overall activity of the brain. So these are the two approaches, and depending on the use cases, you will either go try to deep down for the specific neuron, or you can like satisfy yourself with just like a generic approach and outside approach with the non-invasive. And that's what we're doing on our side, is non-invasive. Now for the second part of your question, yeah.
No, go ahead.
Yeah. So for the second part of the question, which is like, how do we differentiate ourselves from the rest of the non-invasive? One of the big complexity of the neural interface is to reduce the size of the device that's capturing the signal. Like if you think about like non-invasive today, usually you imagine like these big caps with like electrodes all over the place and like sometimes even gel that are going to like ruin your hair for the next 2 weeks, So one of the things that we've been working on for the past 5 years is how do we bring the tech outside of the lab into a device that people are already wearing, and how do we do that while still capturing a good quality of the signal and also providing value for the user. And so that's really the past 5 years of R&D that we've been working on, and a bit of our secret sauce on how do you miniaturize everything into what I'm wearing on my ear right now, and how do you make sure that you can read that signal and transform it into, in our case, very simple control that are hands-free, voice-free, with a 99% accuracy for the user.
So there were a lot of promises there, Yacine, when you mentioned like lightweight, something that goes in your earbuds, 99% accuracy. What I want to show is a quick video, just to give people an impression, right, of what we're talking about that I actually got from Wisear itself. And then we're going to go back so you can tell us exactly what you can do with this device.
Okay. Sure.
So in the video, we saw an example of what is this reaction or detection of the facial muscle. But I know that there was much more behind it. And this goes far beyond like eye motion and what you mentioned also being silent speech. What can you do with Wisear?
Yeah. All right. So, I mean, I like this video. This was our very first promotional video. It's fun to watch it again. So basically, like, again, like the idea is we are currently working on building a whole set of controls that allow you to have hands-free voice-free controls. I think it's important because there are many situations in our lives where our hands are busy, either momentarily, like in the video, or more indefinitely, like if you have like an accessibility issue or your hands have like limited metricity. That's kind of the promises we worked on from the beginning. And I think augmented reality is bringing another layer on top of that by, okay, how do you control something that's projected in front of your eyes if you don't have a keyboard and a mouse? So all of this to say that there is a need to reinvent the human-machine interface. On our side, the way we've been thinking about this is trying to decompose that in 3 steps. Step number 1 is what I would call selection, which is, okay, how do I replace a click or a press of a button? And that's what we're using with facial muscle activity. So the way it's going to work is that we're going to leverage micro contraction of the facial muscle. So that can be, for instance, clenching your jaw. Like if I do it like this, you don't see me doing it, and yet I've done it. So it's completely invisible from the outside. So micro contraction, and then when I do that, actually the nerve communication from my brain to my muscle and the actual muscle activity propagate electricity captured by the sensors, and then we've trained algorithms that are running directly on the device to read that activity, and when they detect the pattern of me clenching my jaw, simple click, double click, triple click. That's number 1, that's the selection. The second part is what we call the navigation, which is not showcased in that video, but that we've developed since then. And the navigation for us is we're using, I would call it like low-level eye tracking or eye gestures. So what we're doing is we're able to detect simple eye gestures like this, like right and left for now. We're going to work on the verticality soon. And being able to use that to like swipe through apps, for instance, or navigate, through a very simple interface that could be projected in front of your eyes, or go to the next one if you're playing music on Spotify. And finally, the last part, and this part I won't be able to tell too much about it, but the last part is once you have the pointer, like once you have the selection, once you have the navigation, how do you actually have complex commands or complex inputs, like text inputs? And for that, we're trying to work on something called silent speech, where the idea is to leverage the muscular activity that's generated by me talking and interpret that without, for me, the need to actually pronounce the words. So I could be saying, hey, I'm Yacine, I'm happy to meet you. And I'll be like, and that would be enough, and basically we'll be able to capture that muscular activity and reproduce the text onto whatever device that we have in front of us.
So the next point is to understand from an individual, right, that get this device for the first time, how is there any sort of calibration needed, or what's kind of like, I'm not sure, the learning curve. So at this stage, and then we're going to go maybe more into like accuracy or stuff like this to understand.
Yeah. I mean, so one of the things that's important is like, if you look at successful human-machine interface, and I think the Vision Pro was a very interesting example recently. So if you look at like successful human-machine interface, when they brought to the market for the first time, the one thing that is very important is that you need to be onboarded very quickly. Touchscreen, like it becomes very simple for after a while. Like it becomes very simple in the first usage to understand how it works and to use it. Like the Vision Pro was really interesting in the way they brought it. Like the touching was very natural, or like very close to natural, and then the eye tracking, you will have that very simple, like training that you need to do. So for us, we knew from the get-go that if we wanted our technology to be adopted, we needed to make sure that it works on anyone, anywhere, and it works very quickly. So no need to actually train the algorithm yourself or to do some calibration. We need to make sure that we have an algorithm that's robust enough that out of the box you could use it right away. And we need to make sure that the onboarding would be super short for you to learn the gesture. And today we are below 2 minutes in terms of like the total onboarding for people from the moment they would put the earphones in the first time till the moment they would actually be able to use it to control their music, control Tetris on their smart laptop, or just control like AR glasses.
On Vision Pro, you are in this situation where sometimes you have your eyes darting around, trying to select something, and you are not like sometimes I'm afraid of making mistake or selecting the wrong thing. Because indeed it's not such a common way of interacting with digital content in a way. Even in this case, how do people are reacting to the capability of selecting, for example, with clenching your jaw? Are they afraid of mis-selecting, for example? How likely is that to happen?
Yeah. So the question you ask is a perfect one, because like this happens. I think I will provide two different answers for the facial muscle activity, so the jaw clenching and the eyes. I will start with the jaw clenching. So the jaw clenching, the way we've built it is we've built it in a way that you do not do it if you don't want to do it, if you don't intend on doing it. So it means that you would really, very rarely during the day, just do like one clench or two clench. If you're doing anything, you're going to be chewing a gum, you're going to be eating, you're going to be swallowing water, whatsoever. So what we did is that we defined a gesture that was singular enough that you would not do it by mistake. And then we trained the algorithm to distinguish that gestures among any other gestures, be it like you talking, be it like you chewing, you swallowing, you yawning, you doing anything else basically that would activate some muscular activity of your face. So for that gesture, you don't have that kind of like, I didn't do it on purpose, because like really the gesture is singular enough that you would do it on purpose. For the eye, the question is different. And you're right. Like one of the things, I think there is Tony Scareghost, which is like a newsletter like that I read many, very week basically. And he always has that very simple thing about eyes that I like. He says like, eyes are meant for exploration. And the thing is that if you like use your eyes all the time and as a control, then basically you're going to prevent the eyes from exploring, and you have an issue here. So for me, the eyes are a very contextual control. Like you don't want the eye control to be on all the time. You want the eyes to be contextual, either automatically contextual, like you receive a phone call, okay, glance to the right if you want to take it, glance to the left if you don't want to take it, or we detect that you've just turned on your AR glasses and so you want to swipe through apps, and then once you're done, we deactivate it. That can be automated. Or there can be like a manual one, and here you have a combination of our controls where you could be doing like a simple clenching. It activates the modal, and then like you swipe or you do whatever you want with your eyes, and then once it's done, you close it, you're good to go, and the eyes are not active anymore. And then this is how we've kind of like we're tackling that topic as being like something where you want the eyes to be really contextual and limited in time.
So it is still kind of like hard to imagine this in action, right? I want to be very honest, right? Is that something that you can share or something you can show us to give us an impression of how this works?
Yeah, absolutely. So yeah, what I'm going to be doing is that I'm going to be showing you a couple of our demos to kind of let you understand like how our controls can help on a daily basis. I'm going to show them a laptop because it's easier, but you can easily understand that this could be translated on mobile. It's exactly the same thing, right? So I'm going to show you right now how you can control your music just using our controls. Okay, so right now you should be seeing my Spotify, and hopefully when I'm going to be playing the music, you will also hear it. Otherwise, I will just let you see on the screen the little like toggle. So right now the music is paused. What I'm going to be doing is I'm going to be playing it just using a simple jaw clenching, so hands-free, voice-free, and I'm going to do it right now. Okay. All right. So now it's playing. Hopefully you can hear it. What I'm going to be doing now is I'm going to be glancing to the right to go to the next song. So I'm going to do it right now. And I can do it one more time. And now if I want to go to the previous song, of course, I can also go back to the previous song by glancing to the left. Okay. And now if I want to pause the music again, I can do it one more time. All right. So this is kind of just basic introduction of how you can use that to control your music. So again, you're running, you're climbing. I'm a big climber, so I often have my hands full of chalk, and so that's not like ideal to have to press a button or whatsoever. So I've been using our other prototype while I'm climbing to be able to kind of control the music easily. And now the second one I want to show you afterwards is just how you could basically control really anything. The one I want to show is like me playing Tetris, basically. It's a cool game to play with, and so I'm going to show that right now to you. And I'm going to start Tetris. So same thing. I'm going to be basically moving the piece to the right, for instance, by glancing to the right. And if I wanted to drop, I can just clench 3 times. Now, if I can rotate it, I'm going to clench once. I can move it. Okay. Okay, now this one, I want to rotate it again. All right. All right. Anyway, you get the jinx of it. So the idea is you can really just plug whatever you want as outputs to these controls that we've built, and you can use them as your new input for really anything you want.
I just wanted to have a quick break to remind you that if you're enjoying this conversation, you should definitely check out the XR AI Spotlight newsletter. By subscribing, you will get weekly interviews like this one directly in your inbox, an app or product I personally have tested and recommend, and access to a list of over 400 mixed reality apps for Quest that you can easily search and filter. Just check the first link in the show description. And now, let's get back to the show. So I suppose that one of the core metrics that you're trying to test and track with users is, for example, the missed attempts or the false positive. Based on what you said, the false positive are very little, right? Because you were saying that, let's say, the eyes are contextual, so they are activated only in certain situations, while instead for the clenching they've been trained not to be that, let's say, prone to this false positive. But what about, for example, the miss attempts? How have you juggled that, and what can users achieve nowadays?
So that's a very good question. So the way we try to the metrics that we work on, which is kind of the same as so okay, let's say that there are two metrics that we're working on. There are internal data science metrics, and for this case, we're using precision and recall. And so here, let's say that precision is out of all the gestures that you try to make, how many are correctly detected. No, sorry. Precision is out of all the gestures that we detect, how many are correctly detected. And recall is out of all the gestures that you make, how many are we properly detected. So what you want is a very, very, very high precision. So you want to make sure that whenever the user, out of all the gestures that you have, none of them are wrongly predicted, because there's nothing more annoying than having to having your music pause automatically without you wanting it, right? So this kind of translates into a metric that we like and that's easier to understand, which is the number of false positive per hour. So which is how many times does the thing trigger by itself over the course of an hour. So if you look at, for instance, the Alexas and all the voice assistant of this world, they're roughly at 1 per hour. They will say less than that, but let's say that if you're at home, you're going to be between 1 per hour or 1 every 2 hours. Today, we are at 1 per hour on our case, and we're trying to reduce that. And the stat is different for the jaw clenching and for the eye. For the eye, we're slightly higher because the technology is still in development, and we don't have as much data. For the jaw clenching, we are at a much higher point. What's important is that we have multiple things that we're currently implementing to make it better over time. One of them is indeed calibration. When you receive your Alexa, you can talk to it so it trains on your voice. That's kind of the same thinking here.
So what about instead the miss attempts? So when you actually want to do something and then instead is not detected or as fast or as accurately as you would expect?
So these are two different things, right? Fast is very important too, because you're right. Actually, something that actually didn't help on the voice assistant until the most recent update is when you are asking your voice assistant to pause the music, it would take forever to do it versus just pressing a button, right? So on the speed itself, today we are as fast as your button on your AirPods. So the way we test that is we ask you to do the gesture, we ask you to press the button, and then we ask you to rank which one is faster than the other from a user feeling standpoint. From a pure metric standpoint, it means that our controls are triggered in less than 1 second. And below 0.3 seconds, you don't even feel it as a human. So that's where we are. In terms of like the missed attempt, so the false negative in this case, false negative, we do are at 98%. So that means that like out of 100 gestures you're going to make, there are 2 that are not going to be detected.
So, and I mean, to achieve all this, that honestly, it sounds pretty mind blowing, right? I mean, like, what were the kind of like challenges that the hardest challenges that you had to face, and how did you solve them?
Actually, so many. We were not expecting that at first. We really thought it would take us less time to get there, but like, we had to face these challenges. I think originally we thought it was mostly a software problem. So Ala and I, we come from the AI part of the world. So we mostly try to tackle that as an AI problem. And so AI slash software. So signal processing as well. So what we worked on was really, okay, what was the data that we need? How do we collect that data? What are the different type of like other gestures that we need to train the algorithm on so that it's like super robust? And then on the signal processing, how do we make the signal processing happen in a very, very short fashion? So we have a couple of patents on like new method for signal processing that we have developed to make the signal processing happen in a very short amount of time without deteriorating the quality of the signal. So we really handle that on like AI slash software standpoint. This was the very beginning of the project, but then we realized very quickly that we could not have any good AI without a very good underlying data collection and therefore hardware. And then we opened a whole new Pandora box. That's where we hired Camille, who's our head of hardware, and like he's a former guy from SoftBank Robotics, and Enzo, who is our head of software and firmware, and who basically used to work in IoT. And so they really helped us kind of amp up to the next level, where basically we, on the hardware side, was okay, what are the right sensors? How do we make sure that this thing is comfortable so that you would wear it all day long while maintaining a good contact between the sensor and the skin, which is kind of what the requirement is about for the technology to work. And then on the firmware side, it was okay, how do we make sure that these big algorithms we built in Python on desktop can translate properly so that it fits onto a chipset that's like super small and that fits into that earphones without deteriorating the battery. So I would say, yeah, these 3 main challenge: AI, data collection, hardware, sensor, and comfort. And then on the firmware side, how to optimize everything to run a small chipset.
So this feels like something that is close and it's getting closer, but it's not there yet, right? Now, first, what I would like to understand is also what market are you currently targeting and what kind of decision went into picking that option?
That's the $5 billion question. So basically, product-wise, we intend on releasing a first product at the end of 2025. I think we've never been closer. Like this, what you're seeing right now is like the latest prototype, but it's also the form factor we're gonna use for our first product. We still have a couple of things to fix along the road, but like we're targeting Q4 2025 as our product launch. So that's for the getting closer. In terms of the markets, right now we've seen traction and we've done prototyping deals with quite a few companies at this point in multiple markets. The one thing we've learned from there was that none of the companies that we talked to were willing to integrate our license or our technology until we've proven that there is some market traction on some part of the market. So the market that we're going to go after because this is where we've seen the biggest pain point we can solve is the accessibility market. So the first product we're going to be launching is going to be targeting the accessibility markets to enable people who have like limited hand motricity, whether it is like temporarily or most likely indefinitely, to be able to control their smartphone, to be able to control their laptop, to be able to control their XR devices, their AR devices, without using any kind of controller, keyboard, or mouse to help them. So this is really where we're going to start. But the idea is to use that more as like a beachhead and then expand to every other industries, either through our own products or through partnership and licensing the technology.
So can you explain me a second this accessibility part? So
Yeah.
I get it. If I have limited hands mobility and I cannot do a certain kind of actions, I can use Wisear, makes sense. But what would stop someone that could just want to use that? So how does that saying the accessibility market, what makes it different that says, okay, it's a consumer product?
Yeah. So 2 things. One, I don't think anyone that I don't think that if anyone wants to buy this product and use them for themselves, like we should prevent them from doing so. The device will be compatible with every laptop, every smartphone, every like XR device out there, whether or not you have mobility issues or limited arm mobilities. What we're just talking about right now is the potential integration with some of the software that these audience is using, or just the marketing that we're going to be making. So I would say from a device standpoint, it won't change much. And I would not expect that device to change much more between the version that we're releasing right now for the accessibility market and maybe a more consumer version that would be dedicated for someone who wants to play with it or use that with their extra device. It's just a matter of like, what is the marketing effort that we're doing and how do we focus this marketing effort?
So the point is also, and that is dependent on what is specifically the use case, the kind of market is, you decided to pick earphones first.
Yeah.
It could have taken another shape, I imagine, right? So why earphones? Why not something that could have had a different form factor, or maybe targeted more toward, for example, industry, let's say, for example, on a shop floor, let's imagine, to do hand-free, some maintenance or so on. So how did those two factors, both like industry use cases as well as the actual shape of the sensor, played a role?
So maybe I would take a step back here. I think our long-term vision is to be able to have our technology compatible with any hardware. We've actually had a few integrations or prototyping with like industrial AR headsets, and so integration with like either a headband or like glasses and so on. I think it's a matter of so the long-term vision that we want to be able to support them all, either through our own product or through direct integration in their product. So what you're bringing as like a potential use case is the correct one. Now, what we've been working on is like we've been trying to figure out what's the form factor at first, where if we crack it, we're going to be able to expand the fastest possible way and provide the technology to as many users as possible. And today, for instance, wireless earphones or like ear form factor is a form factor that has like so many like applications. I think it's like 400 million or 500 million that are devices that are sold every year. So whether it is for industry, because it's going to be like your ear protection, whether it is like for your personal usage of your AirPods, whether it is for like any other use case you would have, like sports earbuds or whatever. This is a form factor that allows us to open as many clients and as many users as possible. So that's why we started with that. Later on, if there's another form factor that picks, say, smart glasses, which we do believe is going to happen, then we know we're going to be in there as well, right? It's just a matter of, like, I would say, which one is readier, and we need to launch a product next year. We need to start generating revenue. So we're starting with the one that has the biggest impact at first.
So, I mean, you mentioned, of course, smart glasses, right? And I think that was one of the things that also from the announcement of Orion, like a few months ago, I think passed a bit unnoticed in a way. So it was there. Everybody was crazy about the glasses. But when you look at this band and people, let's say, having so much more control and options just by, for example, slightly moving their fingers or with these micro gestures, so to say, I think it has a huge potential. So one question from you that has been doing this and been to this industry for so long, like, how do you see this moving forwards? Like, how will humans interact with interfaces, and how will that evolve in the next, let's say, 3 years, 5 years?
Yeah, I don't have the exact timeline in mind. The way I see it is that if you look at the way we use technology today, we are all using it in slightly different ways. The human-machine interface to control your smartphone, to control your laptop, to control any device is not the same for everyone. Some people will use voice for some applications. Some people will use like typing. I use a lot of keyboard shortcut. I try to not use my mouse at all, as little as possible. So we all use technology in a slightly different fashion. What I do think is that I don't think there's going to be like a one single winner that's going to control everything. Apple tried to push the thing with like, oh, we're just going to have like this and the eye. I don't think this is the right answer. I don't think this is the combo that I think it will help like for many use cases, but maybe for gaming, you will need controllers. I don't see how you can do just these things without controllers. For hand intensive task, you're going to have to do like use some kind of way, like, if you want to do like industrial design, like in 3. So depending on the use case, you will have needs for additional human-machine interface. I think we're going to provide one for when your hands are busy and for when your voice is not an option. And that's really where we position ourselves, like hands-free, voice-free, screen-free if you want, because we don't even need a screen to use our technology. And I do see these technologies that are going to evolve and be available to the market. And then, hence the question that you asked before, which is the right one, was the first market. Where do people need you the most? And that's who's going to be using your human-machine interface the most compared to others, for instance.
Yeah, and I think you made a very good point, to being the specificity for the use case or for the type of things that we are doing. Because again, in some cases, you wouldn't want to have the full control swipe increase in size.
Exactly.
Or swipe, right? You just want maybe a click and a tap, and that might be enough, given the extra advantage that you get of doing that without the hands.
Yeah.
On the other hand, there is also, I think sometimes people don't get it. It's like, okay, I want to do the same thing that I'm doing on the Surface on my phone or on my keyboard and my mouse, same thing, but I want to do it with neural interfaces. Well, maybe you could, but then we are talking going back maybe to that invasive solutions, right?
Absolutely. I'm aligned with you. Like, I really don't think it's a replacement, and like it's really just the same way that voice did not replace, like, even if you're not using voice for everything, you're using voice for specific use cases. So we're just increasing the panel of everything that's available to the user. And I agree, if you want your neural interface to be as precise as your mouse and keyboard, at this point, I don't think, I mean, even with invasive, you're not able to do it. Like the way, like what Neuralink is doing is just like controlling a mouse cursor or like navigating through a keyboard. But like, it's not, we're nowhere near what you can do with like a mouse and keyboard yet, So it's going to take some time.
Yacine, I do have one last question, because I need to ask, and that's, what will be the price range right now for Wisear coming to the market at the end of 2025?
And you know what? I should have mentioned that earlier when you asked me what's the key differentiation. Because like one of the things that's been a problem, I mean, not a problem, but like that's kind of prevented the technology from going to market, is the fact that all the components were super expensive. And if you look at like every electronic device out there that's equipped with like neural interface, we are way beyond the 1,000. Even OpenBCI, who was trying to make this like more affordable, like you're way beyond the 1,000. For us, what we've been doing since the beginning is really work on like having the lowest possible BOM cost and optimizing towards that. So today, like the price point that we're aiming for these first earphones is going to be $250, which is going to be kind of aligned with like premium headphones. But we want to be aligned with the price point of the earphones market and not be a device that's completely outside that range. So so that's what we're aiming at, and we've been working on that BOM cost, and I've had to fight with people from my team to make sure that we would get there. But that's where we should be able to sell the product to.
Yeah, and I imagine also the manufacturers, because I've heard that every time there is a hardware startup, there's always that element of dealing with suppliers and all that. That is another layer of complexity. But absolutely, it sounds incredible. I was actually one of the folks that got reached out to, and that's how we got in contact, asking some opinions about it. I really look forward to test this, because it does seem like the future and something that makes absolutely as the next step from the phone or from the just double tap.
Yeah, I think you need to start simple. We don't intend on like replacing your whole touchscreen right now, but if we can start simple and we can already provide value to users with that, I think we've already made a big step out there. And then like from there, we have a huge roadmap, like on everything you can do with that type of signal. Brain signal can be useful. So you have like a bunch of health applications. This is in our research pipeline, but like, this is just like, baby step by baby step. But if we manage to get there and help you, we're down. And we're going to have a beta that's going to be opening hopefully in end of Q1 next year. So if you're into it, I'd be happy to count you in,
Awesome. Yacine, I'm gonna sign up for sure. Thank you very much for being here.
Sure thing. My pleasure. Thank you very much.
Thank you very much for listening in. If you like the show, remember to leave a rating on Spotify, Apple Podcasts, or a thumbs up on YouTube. It really helps me keep doing this and shine the spotlights on the greatest founders and makers, pushing the boundaries of XR and AI. Also, make sure to check out the show page, xraispotlight.com, where you can find more conversation like this one. Till next time.